All right, so 7.6 notes. We're going to talk about special parallelograms today. Shadow's going to drive me crazy. That's okay. All right, so our goal for today is going to be to identify properties of rhombuses and rectangles and then to determine if a quadrilateral is a rhombus or rectangle. Now, if it falls under both, then what kind of shape would it be?
Square.
A square. Good. Can you guys see that okay? I might end up shutting these blinds. Alright, that looks better. Alright, so each diagonal of a rhombus bisects two angles of a rhombus.
Good morning, teachers. Please pardon the interruption. Please send down all juniors who have yet to receive the front load. Thank you.
So each diagonal of a rhombus bisects two angles of a rhombus. So if we have a rhombus, which is what we have in this figure, I know this is a rhombus because all four sides are the same. Okay? But if I take and draw in a diagonal, and the diagonal could have been in the original one too, it doesn't matter. But if you have a diagonal of a rhombus, okay, what happens, and you might even recognize this, what kind of shape is that rhombus cut into? Two triangles. What kind of triangle is this one right here? Does anyone? That's an isosceles triangle. Okay? So, if this is an isosceles triangle, then I also know that these two angles are the same. And I could prove, using some theorems that I know about proving triangles congruent, like this is a shared side, so I'd have side, 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 and side, 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 so I could prove that this triangle over here is the exact same triangle, also an isosceles triangle, and that all four of these angles would then have to be the same. Insane. Fun. What's that? Yes, yeah, it's still a rhombus, so you could have cut the diagonal going this direction, and yes, then those four angles would be the same. But these four are not going to be the same as the other four, because B is not going to be the same as A, right? B is, in this one, you can see that A is obtuse and B is acute. Okay? Because they're supplementary, they're not all going to be the same angle. There is another rule about the diagonals, and this one we're going to draw in both diagonals. If we have diagonals in a rhombus that are drawn in, then there's an additional label we can put on those. So if we draw in the diagonals, we also know that they will be perpendicular. So if we have diagonals drawn in on a rhombus, we also know that on a rhombus, they're also perpendicular. Okay? So we could write that out as segment AC is perpendicular to segment BD. If this applies to a rhombus, what else would it apply to? Is a rectangle a rhombus? No, rectangle's not a rhombus. Okay, but what other shape is a rhombus? A square. So this also applies to a square. So I'm going to put up over here also for a square. Because a square is a type of rhombus. It's a more specific type of rhombus. So if this one up here also applies to a rhombus, what do we know about this one? That it's also going to apply for a square as well. Because a square, again, is a rhombus. It's just a more specific type of rhombus. Alright, so moving on down to the next theorem. It says the diagonals of a rectangle are, so if I draw in these diagonals, the diagonals of a rectangle are going to be congruent. So this means that the length of AC has to equal the length of BD, or that segment AC is congruent to segment BD. Remember, your lengths are equal, but the figures themselves are congruent. If this applies to a rectangle, what is another shape that is also considered a rectangle? What is it? A square is also a rectangle. So this also has to apply for a square. Because a square can be defined as a rectangle with 4 congruent sides. Or a square can be defined as a rhombus with 4 right angles. That's why a square works for anything that a rectangle or a rhombus works for. Okay. Questions on these 3 theorems so far? Okay, so remember that these do not apply to any parallelogram. There's a reason that today we're learning just about these theorems to be special parallelograms. Because if I have just a random parallelogram here, okay, these diagonals are not the same length. As I showed earlier, I can push these ones. You can see that these are pretty close together. And these two opposite, these diagonals, are nowhere close to that close. I can't even reach with my hand across those, but I can with this one. So, because of that, I know that these diagonals are not congruent on a regular parallelogram. But if I make it a rectangle, that's the only parallelogram where the diagonals are then going to be the exact same length. When I say a rectangle, though, I could also be including a square, because a square is a type of rectangle. Do you see how that works for a rectangle but not a parallelogram? So, a lot of times, many years of me teaching this, I see that people automatically assume that all the properties apply to all parallelograms. we're going to have to remember which ones apply to which parallelograms, because these ones only apply to the specific parallelograms, such as rectangle, rhombuses, or squares. Okay. All right. So for your cheat sheet on your test, these would be really good to put on there, which rules apply to which shapes. Okay. The next theorem says that if one diagonal of a parallelogram bisects two angles of the parallelogram, then the parallelogram is a rhombus. So this is just the converse of that first one we talked about today. It says that if we have a parallelogram, so you should be marked parallel, so I know that it's a parallelogram. Okay, so if one diagonal of a parallelogram, so we have a parallelogram with a diagonal, and it's bisecting two angles. Okay, so it's still bisecting those two angles over here. Okay, so if we have this, then we know that this must be a rhombus. So what that allows us to do is it says, oh, then all four of these sides must be congruent. What's that? Well, we just know that it's a parallelogram, and if it says that these are congruent, because this is being bisected and this is being bisected, then we automatically know that this must be a rhombus then. Because if it was a parallelogram, these would not necessarily be bisected. But if they are, then that means that it's a rhombus. Okay. Which allows us to say that this side is congruent to that side, which is congruent to that side, which is congruent to that side. So all four sides are congruent. We flip it over. We have another converse, and it says, if the diagonals of a parallelogram are perpendicular.
Good morning, teachers. Please pardon me interruption. Please send down all sophomores who have yet to receive a copy. Thank you.
Then the parallelogram is a rhombus. So if we can see that the diagonals are marked, we can see the diagonals are marked and they're perpendicular, then we can say, oh, that means that all four sides must also be congruent. Okay. I would have also been given that this is a parallelogram, so I would have been given that these are parallel and these are parallel. Or maybe just told it's a parallelogram. Then have those marks on it. So I would know that figure ABCD is a rhombus. The next one says that if the diagonals of a parallelogram are congruent, then the parallelogram is a... So if we have a parallelogram here, so here's how it's a parallelogram. I have my marks showing that the opposite sides are parallel. And it says that the diagonals, it says AC is congruent to DB. Then, what do we know? Well, if you look, we're just doing converses here. So the one that said that the diagonals are congruent went with a rectangle. So we'll then know that this figure here must be also a rectangle since the diagonals are congruent. So that means A must be a right angle, B must be a right angle, C must be a right angle, and D must be a right angle. This is not drawn to scale. Okay. And they're not always drawn to scale, so we have to know what we can identify as being labeled. So let's actually try to put some of these to work then. It says, find the measure of the angles. Explain your reasoning. So, looking at this, what kind of figure is this? A rhombus. I can see that this is a rhombus because all four sides are congruent. Okay, so what do I know about a rhombus? What are those properties that a rhombus has? The diagonals are going to bisect. Angles. Okay. So let's see what we can label here. Our theorem says that if it's a rhombus, then the diagonals bisect angles. That's our reason. We already did our explaining. That's our explaining. Okay. I don't have the theorem numbers memorized. I'm not expecting you to have them memorized either. Tell me in a sentence your explanation. Okay. You don't have to say theorem number blah blah blah. Okay. Just tell me in a sentence. So, based on this, the only thing we know is that angle B is 120 degrees. Raise your hand if you can tell me another angle measure here and why. Go ahead. Why is 130? Okay, so you're looking at this triangle right here? And triangles have to add up to 180? Okay, so what does that tell you? Yes, this is an isosceles triangle. So you know that 1 and 4 have to be congruent. So if the top angle there, that vertex angle is 120, then 1 and 4 have to add up to another 60 degrees, because 60 and 120 will get you to 180. And if these two together have to be 60 and they're the same, the only option is what? 30 degrees. So both of those have to be 30 degrees. Let's see what else we can label. Okay, I still need 2, 3, and 5. Go ahead. 5 is 120. Why? The opposite angles of a parallelogram are congruent. Okay? So the measure of angle 5 has to be 120 degrees, since opposite angles of a parallelogram must be congruent. Okay, what can we label now? The 2 and 3. Okay, how can we label 2 and 3? They're both going to be 30 degrees also. Why? Again, we have an isosceles triangle, so you can look at it this way. That's actually using old information that you already knew. You could use the new information, that the fact that the diagonals have to bisect each other. And the way that we would know is we would have labeled 1, 2, 3, and 4 have to all be congruent. And if we label that and we know 120, what are the angles next to each other? If angle B is 120, what does the entire angle A have to equal?
60.
Has to be 60 degrees, because A and B, angles A and B, have to add up to 180. Those are consecutive angles in a parallelogram. So you could have gone that route as well and said this whole angle has to be 60. And since it's a rhombus, I know that this diagonal is cutting it in half. So if this whole angle is 60, each of them have to be 30. And then I could have done the same thing here. 120, that means that has to be 60. Cut it in half, each of them have to be 30. So that would be how you would use your new rule. But yes, you can still use the isosceles triangle rule. I tend to use that because if you're really good at isosceles triangles, then you're not having to learn anything new here. That's why the theorem is the way that it is. It's using previous information to come up with that new theorem. Okay, it has to do with the isosceles triangles and that these two triangles are going to be congruent. Okay. So I think we labeled everything. Number 2 says, find the length of FD. So FD is the length of this diagonal here. Okay. Find the length of FD in rectangle GFED. If FD is 2y plus 4. So this whole thing here is 2y plus 4. And then GE, G to E, is 6y minus 8. Explain your reasoning. So what do we know about the diagonals in a rectangle? They're congruent. So the diagonals in a rectangle, we have a rectangle, and we know that the diagonals are congruent. So if the diagonals are congruent, we know what? They have equal measures, right? So how would I set this up then? Yeah, you're just going to set FD equal to GE. We know that if these segments are congruent, then they have to have equal measures. GE and FD have to have equal measures. So then fill it in. FD is the 2y plus 4 equals GE is 6y minus 8. I got that. Because the blue has to equal the pink. And from there we can solve for y. Subtract 2y on both sides. Add 8 to both sides. For y will equal 12. Divide by 4 on both sides. Y will be 3. Am I all done now? No. Usually what happens is people accidentally stop there because they say, oh, I found a variable, y is 3, done. What is it they want you to find? What is it you're looking for? The length of FD. So let's find the length of FD. FD is equal to 2 times y plus 4. Well, FD is equal to 2. Y was 3 plus 4. So 6 plus 4. FD has to equal 10. Okay. If I had to go and find GE, which right now it would probably be a good idea, I'm already almost done, so why not find GE? GE is found by taking 6 times y is 3 minus 8. What should you notice about the length of FD and the length of GE? They should be the same. 18 minus 8 is 10. I got GE was 10, which is also the same, which makes me feel a little bit better because now I can check and say, okay, those were supposed to be the same. They were, so I found the correct y. I'm done. Okay. The assignment for this. You guys have plenty of time to get started and work on. 1 through 9, it's asking for the angle measures. Okay, so remember for this, you want to make sure you're showing me, even if you're typing it into a calculator, just show me what you're typing in to show your work. Okie doke. So you should have some form of work for 1 through 9. Finding all those labeled angle measures. You can label them right in the diagram. Put your adding and subtraction math around the outside. 10 through 13, you should have an algebraic setup because you need to find x and the length of each diagonal. So you should have algebraic setup, find x, show me that you plug them back in, and find the lengths of the diagonals on these ones down here. Number 14, it's just a cookie cutter proof. So see if you can figure out, okay, if this is a rhombus, what is given? What do we know about a rhombus? Or, I'm sorry, if this is a rhombus, that's given. What else do we know? They gave you 2 of the things that we know. Why do we know that AB is congruent to AD? Why do we know that BE is congruent to DE? Okay, see if you can come up with one more reason, and then you're proving using something with side, side, side. What's side, side, side prove? What does side, side, side prove? What do we use side, side, side for? To prove two triangles congruent. So that means E must be a triangle blank is congruent to a triangle blank. Okay? Oh, then you know parts. Ooh, what was that phrase? CP. Yeah, CPCTC. Okay, so if you have two triangles congruent and then you say parts are congruent, it's probably from CPCTC. So this is using some previous information as well. See if you can break that down. You have a multiple choice question, no big deal there. For these, it says to create a key, okay? So all that means is like maybe you want one of these, maybe a parallelogram will be a star. And then you go through and you say, okay, all sides are congruent. Is that a parallelogram? Yes or no? Put a star or don't put a star. Put a star or don't put a star. Maybe your next one's going to be a heart or a diamond or, I don't know, whatever you want, okay? But that's what it means by create a key. 26 through 28, it says find the values of the variables for each parallelogram. These ones go back to just standard parallelograms, so they may or may not be a special parallelogram. You have to decide. Okay. So that is the brief overview of the assignment.